Right, so with this situation here, roadside, okay, you'll notice in part A and B, they mention a thrust in A, tension in B, okay, so the forces aren't always going to be tensions, there might be a thrust. And they're talking about a thrust in AB, because if you think about it, in order for this sign to sort of stay in place, okay, for it not to move, in a sense, this bar here, this rod, needs to be supporting A. It's almost like giving it a push up, whereas of course the tension is in this rod AC, because it's like pulling it back, isn't it? It's pulling it back and attached to C. So we've got a tension there, which we'll call, say, T1, but it's a thrust here, okay, which we call T2. And that's important. If you think about this, if this wasn't here, if this rod wasn't here, okay, then all you'd have is this tension to support this side, and it might not be so stable. So hence why you've got this rod in place here, which is sort of push. It's not pulling, it's pushing. Think about it. If you try and visualize it, this rod here is holding this in place, holding this sign in place, is pulling it back. Whereas here, this rod is actually pushing up to sort of support it. Now the issue you've got is when we draw a force diagram, right, is we can't have forces going towards the center, all right? And in this case here, the center of my force diagram is going to be A. Okay, so when I start to draw out my force diagram down here, I'm going to have A, okay, at the center. Of course, we could start off with the putting the weight in, okay, which the weight of this side is 12 kilograms is the mass, so the weight is going to be 12 times G. But that's going to be at A, okay. We could have the tension then coming from A, that rod AC, which I've called T1. Alright, but this thrust here, we can't just have the force going towards A. It's got to, all the force has got to be going away from A. It's like a tug of war sort of thing, where there's a weight in the middle and everything's pulling at that weight, pulling away from that weight. So we can't have something pushing at it. So what we need to do is just imagine this, because this thrust is pushing that way. We need to imagine it as if it was a tension pulling the other way. That makes sense. Okay, so we can think of it, that line continuing. The thrust there would be equivalent to a tension here. Okay, now you could, instead of having this, you could have a rod here, couldn't you? You could have a rod there with a tension in it on that weight to keep it stable. But of course that's not practical, in a road situation. You can't have a rod coming out on the road like that. Okay, so you've got a thrust here supporting it, right? You've got a rod here with the thrust supporting that weight. But we can think of it as the equivalent of a tension coming away from it. So I'm going to have it going that way. Now in terms of angles, what you'll find is it's very symmetrical. So because of course we've got alpha there, this is going to be alpha as well. Okay, opposite angles are equal. And of course we're told sine alpha is 0.6. Okay, now if sine alpha is 0.6, you can get cos alpha easily enough, because remember, sine squared alpha plus cos squared alpha is equal to 1. Okay, the rule you learned from C2. So 0.6 is what sine alpha is, 0.6 squared, cos squared equals 1. And of course you can get cos squared alpha then will be 1 minus 0.6 squared. And then of course you've got to square root it. So I do 1 minus 0.6 squared, I get 0.64. And then square root it, I get 0.8. Okay, so cos alpha is 0.8. So now we can resolve vertically and horizontally. Okay, so if we look at the forces here, remember in this case, because this is something that's happening in the vertical plane, it's a roadside, you think of it as vertical and horizontally. So we've got 12G going that way, we've got T1 going that way. Now T2 then resolved along here will be T2 cos alpha, and then T2 sine alpha along there. So because it's all balanced, we can simply say, look, T2 sine alpha is equal to 12G when we resolve vertically. Okay, of course we know sine alpha is 0.6. So we could say then, look, T2 equals to 12G, 12 times 9.8. Take the sine alpha over and divide by sine alpha, which of course was 0.6. My calculator, I get 196 newtons. And if I resolve then horizontally, again I could say, look, forces to the right equals forces to the left. Now I know T2 is 196, okay, from part 1, and I know cos alpha is 0.8 because I've worked that out. So straight away then I can get my T1 to be 156.8 newtons.